Before we get started with today's repair, I just want to give a shout out to one of my good friends, Jason, at Engineering Scale Models on YouTube. Engineering Scale Models is doing quite a lot to help me and a few of the other community members to build a pretty detailed diagram of the Nintendo Switch. So if you could head over to his channel, there'll be a link down in the description down below, and show him some love by subscribing and watching a few of his videos. That would really mean a lot to both himself and to me as well. The link will be in the description, but I just want to thank everyone in advance for showing him some support. And let's get him to 1,000 subscribers before the end of the year. Right, hello there ladies and gents, welcome to another repair video. Today we're going to be taking a look at this Nintendo Switch which has been sent in. This particular console has been sent in because, and I quote, "An error has occurred when charged battery is connected." So this is a bit of a different one. So hopefully we can figure it out and hopefully we can get the console fixed. So I'm going to do what I always do every time that I get a Switch in for repair, and that is going to be to take a look and see what kind of current is being drawn from the plug or from the wall. So I'm going to plug in my USB amp meter and plug that into the Switch, and we get 0.09 volts and nothing on the screen. Right, I've come across this once before, and the issue was related to, you guessed it, M92T36, the power management IC that's responsible for power distribution on the Nintendo Switch. So I have come across this before, like I say, so it's not a new issue to me. But of course we will do some diagnostics and make sure that it is that issue before we go ahead and change the chip. I have just posted a video today and I said it was the M92 chip on that one, and I was completely and utterly wrong. It was on the completely different side of the board. I won't tell you what was wrong with that, I don't want to spoil it, but you should go ahead and check that video out. I'll leave a link up in the top right hand corner in the iCard to that video. Okay, so with the back housing removed, what I want to do first is I want to try and replicate the issue that the customer is claiming is happening. So I'm going to get a charged battery and I'm going to attempt to power the console on and see if we can figure out what's going on with this console. So here I have a known good Nintendo Switch battery, albeit a little bit covered in thermal paste, so I'll just give that a clean so I don't get it all over the customer's board. But this is my known good battery, which I confirmed was fully charged last night, and this is, or should be, on 100%. So I'll just clean as much of that off as I possibly can. There we go. And let's plug in a known good battery. Let's see if we can replicate the issue, and then we'll see if we can fix that issue. So plug that in like that, and then we'll just leave it hanging temporarily on the back of the console. And let's try and turn it on now. And we'll get the Nintendo logo. Boot on him. And then 2101-0001. Okay, so that's a generic error code, and like I said, I have seen this before. So what I'm going to do is I'm going to take the board out of the console. I'll get it under the microscope and we'll see if we can find the issue. Okay, so taking a look on the motherboard then, if we look on the front of the board, just directly in front of the USB port, we'll see that we've got a QFN style chip here. This is the M92T36, and this was the culprit last time I found a issue on boot up where it displayed that particular error code. It's usually related to a hardware issue, and that hardware issue is usually a power issue. So I would say that we're probably going to have an issue around here somewhere. One thing I have noticed is this board looks absolutely immaculate. It looks like that someone's treated this very well, and considering it's just randomly died, it is very strange indeed. So what we're going to do is I'm going to pop the multimeter into continuity mode. Continuity mode is the mode that's going to beep when we complete the circuit. So what we do here is we pop one probe on ground, and then we're going to test the input side of these capacitors. So let's check all of these caps individually. We'll start with this one here. No short. And straight away we've found a short on cap number 2. And no short there. We have a short here. No short here. Let's carry on down. No short there. Let's move on to these ones just here. No short there. And no short there. Well, that's good because that means P13 should be good. P13 USB is the HDMI controller and also handles some USB-C inputs as well for the Nintendo Switch. And usually when we've got a short on these left-hand caps on the side of M92, I believe it is this one in particular. But usually when we've got a short here, we'll have a short on P13 USB on the back of the board. Okay, so moving on to BQ24193, this is the battery management IC or the charging controller. And what this does is this handles power coming in from the battery and power coming from M92T36 into the battery. And it pulls it down to the correct voltage and handles all of the voltage exchanges for the battery to be able to charge the battery safely. So this chip also sends a signal to the battery IC, so the IC that's on the battery logic, to tell it to turn on when a charger is plugged in if it's completely dead, and the battery will not turn on unless it receives a signal from BQ24193. We know that's not the case because it is turning on with a battery and the console is just giving us an error when it's trying to boot up. So we're going to check it anyway, but it's pretty safe to say that these are going to be fine and that we're not going to get any issues on this chip at all. So all of those 5 main caps seem fine. Next, let's check the coil, which is absolutely fine. This coil has trolled me once before, so now I automatically check it before I even go ahead and do anything to the board. So next I want to check this fuse here. This is a 3.5 amp quick blow fuse, and this typically goes when we have an issue with the charging circuit, and in this case it has not gone and it has not protected the circuit, so the fuse is absolutely fine. Next, let's check this filter. So filter number 1 is good, and we do not have a short across filter number 1 to filter number 2, and filter number 2 is fine as well. Okay, so that's most of the checks on this board done. We are going to check these caps around these MOSFETs as well, just to make sure. So we don't want to see any shorts on these caps as well. They seem absolutely fine. So the MOSFET should be okay. Alright, let's flip the board around then. Let's take a look at P13 USB. And this is going to be pretty much the final check for now. So what we're going to do is we're going to pop one probe on ground again, and we're going to check this capacitor here for shorts. So that's good. So now we'll check the filters, make sure that we have continuity on all of the filters. And we don't want to see bridging across these filters. Unfortunately, I have just snapped my multimeter. We should be okay for now. Struggling a little bit with this broken probe. Okay, that's fine. So the filters appear fine, so that's all of the checks done for now. So the only issue that I've found so far is on M92. So let's flip the board around and let's get this chip removed, and then we'll see if that short on on cap number 2 disappears. So just to confirm, one probe on ground. We have a short there. And we have a short there. So cap number 2 and 4 are both shorted. So let's remove the chip, and that should clear the short. So I've got my hot air set to 420 degrees Celsius and an airflow of 30%. And with that chip removed, we'll check those caps once again. So one probe on ground again. And as you can hear, we do not get a beep, which means that short has now gone. Awesome. Right, okay, so let's get another chip installed, and then hopefully this thing will be working again. Okay, so I'm going to install this new chip using the same settings on the hot air station. For those of you wondering, I'm using a Aten ST-862D. Probably the best hot air station I've ever used. I'm not sponsored by them, but it is a fantastic workstation, a fantastic hot air station. Okay, so that's roughly tacked down. So what I like to do with these chips is just temporarily tack it down and then add some flux afterwards. So now I'll add a little bit of flux. And then I'm going to flow this chip back into place properly. So I'm going to increase my airflow to 50% and my hot air to 440 degrees C. Okay, that should be absolutely perfect. So let's clean up while the board is still a little bit warm. Okay, so I'll get the majority of flux off there. And then I'm going to use a toothbrush with isopropyl alcohol as well. Okay, so while I'm waiting for the board to cool down, I want to try and figure out why this has happened. So the way I'm going to do that is by zooming in on the port itself. So as soon as I've checked over these pins here, which look absolutely beautiful, if I do say so myself. So as soon as I've checked over these pins, I'm going to check out the port. Once again, dead center. dead center, and dead center. Perfect. Okay, so what I'm going to do now then, while I'm still waiting for the board to cool down, is I'm going to look at the board on an angle hanging over the edge of the table. I just want to check out that port and make sure that the port is all good and see if it needs changing. If it does, then we'll do it now before we plug it in, because we don't want to blow yet another chip. So let's hang the board over the table and we'll have a look through the microscope. Okay, so it's a little bit difficult to come across on the camera, but through the microscope I'm looking and I can't see any reason why the port might have caused it. Just check those pins with a pair of tweezers, make sure they're nice and solid. And then I'm going to flip the board around. And once again, the port looks absolutely pristine. I do see a little bit of something inside the port, which could be a sign of some sort of liquid residue. So what I'll do is I'll get the toothbrush and some isopropyl alcohol and I'll clean the port itself out. I'll just give it a nice scrub inside, make sure it's nice and clean, and that try and eliminate the possibility of it happening again in the future. Although we can never fully eliminate the possibility. And that looks pristine clean inside there now. No bent pins, no signs of anything in there at all. So let's get this board back installed in the console. Right, okay, so what I'm going to do first of all is I'm going to clean off the old thermal paste and put some fresh MX4 on. Okay, and there is a little bit of thermal paste on the board itself, so I'm going to give it a clean with some IPA as well. There we go. And then I will dry off the CPU area with the cotton swab. Okay, there we go. So let's get some fresh thermal paste on the board then. There we go. And now let's pop the board back into the console. So let's get the connections reassembled, all of these ribbons, and we'll secure the console onto the chassis, and then we can get it tested with a fully charged battery, and then if everything tests out okay, then we'll go ahead and get it all back together. Right, so one screw that I am going to be putting back in right now is going to be this black screw here, because if this console works then there's no other reason to take it apart. If there's no other reason to take it apart, then there's no other reason that we can risk damaging the game card slot connection and then risk having to do a very fragile repair on a connector. So let's get that hooked up, and hopefully that's the last time we have to take it back off. I've got thermal paste all over my hands, which is always nice to see, and there's also an excessive amount of thermal paste on the board itself, which is not nice to see because that means I've wasted it, and this stuff isn't cheap. Oh well. Okie doke, there we go. Let's clean that up a little bit. Turn it into the perfect amount of thermal paste, why not? And let's hook up the Wi-Fi antenna and the Bluetooth. Let's get rid of the thermal paste off the heatsink. And what I'm going to do is I'm going to screw down the heatsink And I'm also going to screw down the USB port to protect that as well. So let's do that now. And I'm also going to secure the game card slot as well, because like I said, we don't want to cause damage to that, and that's one thing that will be tested. So we're just going to secure out the most important parts. Okay, we're not going to be using that battery to connect. We're going to be using a charged battery. We may as well just put the rest of the screws in, to be honest. There's not that many more. There are 3 more screws after this one silver one before we have to put the back plate back on. So we may as well just connect them up now that we've got most of the screws in. One little word of advice, considering this is a error message that's popping up on this. If you're screwing this black screw in here, make sure you don't get the speaker wire trapped underneath the screw, even if you think it's the ground wire, because the chances are you're going to short out the headphone jack, and by shorting out the headphone jack you will get an error on boot up. So that's just a little bit of advice I had to learn the hard way. I fixed the device and I was sat there wondering why I was still getting an error after it had just tested fine out of the chassis, and then I found out that I'd accidentally broken the speaker wire by trapping it under this screw here. So just a little word of advice there, but we're not going to be putting that there. What we are going to be doing is we're going to be plugging this battery in, because this is a known good battery. I know this battery is fully charged because I charged it last night. So let's pop that there. Let's turn it on. Nintendo logo. Boot anim. Dashboard. Yes. Awesome. Right, is the volume down? Yes. Excellent, fantastic. So this is yet another switch which appears to be fixed. I'm not going to say it's fixed because we still need to do some tests, but this appears to be fixed and it appears to be working again. So let's get my test Joy-Cons out. That one syncs, and so does that one. Excellent, perfect. Fan is spinning, which is normal when you connect a Joy-Con because they're connected together on the same circuit. That's absolutely perfect. Right, so far so good. So now what I'm going to do is I'm going to take the USB charger once again, and I'm going to see if it charges on both sides of the USB port. Charging that side. Charging that side. Brilliant. Okay. So one thing I am going to do is I'm going to make sure that it's actually drawing current and that it's not backfeeding into the charger, because that could indicate another kind of issue as well. So let's just make sure it actually draws a normal current, 0.46 amps, and okay, it's going straight to fast charge. That's good. That's even better. So 1.42 amps, and that is straight to fast charge. So let's flip the switch around and let's test it on this side. This will tell us whether it's going to dock. 0.09 is not good. .09 on that side is not good. .4. Okay, so it was just an error with the charger then, by the look of it. Good. 1.43. Perfect. That's fantastic. Okay, so the next thing I want to try is I need to make sure that it's going to dock. So to do that, I'm going to take out my mini dock and I'm going to pop in the USB amp meter to said dock, and the dock is turning on. I've got to be careful now because I've got my own battery plugged in. What I want to find out first of all is it going to register as charging on the dock? So like I said, I've got to be careful here. I don't want to pull the battery out. And it does turn off. So let's see if we get anything on the screen. So I'm going to load up the desktop. So let's load up my camera app. And there we go. So I'm going to press the Joy-Cons. So I'll disconnect one of the Joy-Cons and I'm moving that around, and that appears to be working absolutely fine on the dock as well. Perfect. Okay, so let's lift this off carefully. We just have a few more tests to do. So the next test I want to do is I want to make sure that I can connect to Wi-Fi. There we go, connected to the internet. We should get an updated time now, and 0034 is the exact time, so that is absolutely perfect. Let's check the controllers, make sure they're charging on the Nintendo Switch when they're plugged in. That should be, because the fan spins. So let's plug in a charger port or a charging cable, and we get the charging symbol. Let's check the other one. And yes, we get the charging symbol. That is absolutely perfect. Okay, so the final test then is we need to test the game card. So let's take our trusted Battle Crashers, which definitely needs a clean. So if you can read this one, it can read pretty much any one. So let's connect that up. Might come up game card could not be read. Always does that the first time. There we go. So everything appears to be working. The only thing I'm not testing is an SD card, because I don't know if the customer's already got an SD card that's programmed to this switch, and I'm not sure if it's going to wipe it or allow him to use it again afterwards. So I don't generally test the SD card unless there's an SD card included. So what I'm going to do now is I'm going to shut this down, and I'm going to put it all back together properly. So that means putting the back chassis back on, and then I will charge the battery 100%. So let's plug in the customer's battery, and I'll double check, make sure that everything is plugged in, or everything that I can plug in immediately, and it appears so. Let's apply some fresh thermal paste to this side of the heatsink, because there's meant to be thermal paste there. There we go. Okay. Right, so one thing I have forgotten to do is to connect up the fan, or rather to screw down the fan, and I've only just noticed. So I'm going to correct that mistake before I go any further. This machine needs to come back in the same, if not better condition than it arrived in. And that is a rule that I like to live by wherever possible. Even if that means an extra 5 minutes of work, we're going to connect it up. We're going to make sure that it's fully reassembled properly. And that, my friends, is all she wrote. So this console is now fully back together. It should have no problems charging with the customer's battery, as long as the customer's battery isn't completely and utterly totaled. So let's try and charge it. Let's see what happens. I'm expecting a low current draw. And yes, indeed, 0.38 amps. So the battery's a little bit low. So this is going to take an awful long time to charge. But that, my friend, is one working console. And this shouldn't have any issues charging. It's just going to take around about half an hour to even turn on, because the battery's gone below the normal voltage. So that's going to be it for this video. Let's just summarise on this one then. So this one was originally sent in because it had a 0001 error. That's an error that I've generally associated with M92T36, the power management IC for the Nintendo Switch. And it's a really common chip to burn out, and this time we have absolutely no explanation for it. The board itself was pristine clean, and there was no issues with the charging port from what I can tell, and I've looked at that under a microscope at a pretty close zoom level, and I can't see any reason whatsoever for that chip dying. It's just died. So pretty much just replacing that chip, which by the way is about a $5 chip, or around about £3.50. So this is a very cheap fix if you can do this at home. And this has taken me, even with messing up and leaving the fan unscrewed, it's taken me 58 minutes whilst on stream, and that's going through things slowly. If I was not on stream, it probably would have took around about half an hour. So it's not a hard job to do. It's not an expensive job to do, and if you can do it at home, then hopefully I've just saved you £50–60 at your local repair shop. So that's going to be it for this video. Thanks everyone so much for watching. If you have any comments or questions, leave them down in the comment section down below. I will do my best, as always, to try and get back to you. And if you want to see more repair videos where I try and fix mainly consoles, but sometimes other things too, be sure to hit that subscribe button down below and turn on the bell notifications so that you're notified every time that I upload. I'm also now accepting channel members, and channel members get early access to videos 2 days before the rest of the viewers get access to the videos. So if you want to join as a channel member, you can do so by clicking the join button down below. It's as little as £2 per month, and all members get early access to videos, and it really helps out the channel a lot. But that's going to be it for this video. Thank you very much for watching, and until next time, see you later. Bye for now.